Hello all, I am Jairam. In a series of providing video sessions on C programming languages, as I have discussed different topics under C language in my channel Jairam Tolapati, and subscribe my channel, like my videos. So from the last 1 week I have been providing logic based programs which will help you all while attending for an interview, and if you want to write code on your own, so these logic based programs will help you all a lot. That's why I am providing these logic based programs. So try to understand the logic behind the program, then only you may able to write the code on your own. So let's start our session. In this session 2 I am going to discuss about some logic based programs. So try to understand the logic behind the program. And so this is my channel Jairam Tolapati on YouTube. So if you like my explanation, please subscribe and like my channel. Let's start our session. Here I have written a program on prime number. So first of all, how to check prime number. Here, how to check whether entered number is prime number or not. Here, how to check whether I have entered a number from keyboard. Now I am going to check. I am going to check whether that entered number is prime number or not. Is it possible? Is it possible to check whether the entered number is prime number or not? Yes, it is possible to check the entered number is prime number or not. How can you check means here in this way? So let's see the program. Here I have written basic header files, included basic header files. By using this include keyword, I have included these header files. So how we can include header files and what is meant by header file. So these are the topics I have discussed in my previous session. So try to understand and try to please go there and clear the session there, and understand why I have included these header files into my program. Here I have taken this standard.h and next one is the conio.h. These two are the standard header file, and next I have taken math.h. Why? Because here I am doing some mathematical calculations. That's why I have included the math.h header file into my program. Next here I have taken main method. Here I have written main method which is of type void type. That means this main method hasn't written any value. And here I have written clear screen in order to clear the screen. And next here I have taken n value, which is to take the value from the keyboard, I value for index purpose, and next here flag value to store the real value. Here in the first printf statement I am going to take value from keyboard. That's why here enter a positive integer I have written, and next as soon as I press enter, it takes keyboard value from the user. So that's why here I have taken value. By using this scanf statement I am taking value from keyboard. And next here check the condition. If the value the index value is 2, that means here this is the loop condition. This is the loop condition for the non-prime number. So I equal to 2, I less than or equal to n by 2, I plus plus. Here I have taken index value as 2. So what is meant by prime number? So prime number is prime number, it has divisible by itself, and no other divisible it has. That means suppose if I taken 1, suppose 1, 3, 7, 11. So these are the prime number. Why? Because these prime numbers have no divisors. These are divisors only. These are divisors by itself only. These haven't any divisors. So suppose that's why here I have taken 2. Why? Because 2 is even number, 2, 4, 6, 8, 10. That's why here this is condition is for flag this for loop, and these conditions are all for not even numbers, that means non-prime numbers. So that's why here I have taken a value as 2, and next here I am just a condition. I put a condition I less than or equal to n by 2, and I am just incrementing the value. And next here I am checking the condition. If n modulus 5, if n modulus equal to 0, then flag equal to 1, break. So this condition is for non-prime numbers. And if the entered value, if the entered one is correct prime number, then simply put a message it is a correct prime number, otherwise it is not a correct prime number. So As soon as I press enter, I got this output. You can observe the output on right side of my program. Here I have it asked me to enter a positive integer. That's why here I have entered 7. As soon as I press enter, it displays 7 is a prime number. Why? Because here 7 has no divisors, or that means 7 it has multipliers or divisors is itself only. That's why 7 is a prime number displayed on my output screen. And next here, this is another output, another output example. So as soon as I press enter and it asks me to enter integer, that's why here I have entered 6 as my integer. As soon as I press enter, it displays result. 6 is not a prime number. Why? Because here 6 has many number of divisibles are there. One is one is successfully divisible by 6, and 2 going to divisible the 6 successfully, and 3 going to divisible the 6, and 6 is going to divisible the 6. So these are the different types of divisors are available for the 6. That's why here 6 is not a prime number. Here 7 is a prime number. Why? Because here 7 has only 1 and 7 only are the divisors. No other divisor can divisible 7. That's why here this is the example, this is the program, and this is the logic for the non-prime number value, and remaining these are all the about how we can calculate the prime number, which take the value from the keyboard. And next program here, how to check whether the entered number is palindrome or not. Here palindrome is, suppose I have entered a number, suppose I have entered 3-digit number, and the reverse of number, suppose I want to write the number from the right side to left side, the number would be same. That means if I entered number from the keyboard, suppose I have taken this 1 2 3 as my keyboard, and now I want to reverse this number, that means 3 to 1. So 1 2 3 is not equal to 3 to 1. So when it is equal, then it is called a palindrome number. When it is not equal, then it is called not a palindrome number. Here I have entered 1 2 3 as an integer. So as soon as I press enter, it is displayed 1 2 3 not palindrome. Why? Because here 1 2 3. Here I have entered number 1 2 3. So if you reverse the number, what is the value? 3 to 1. So 3 to 1 is not equal to 1 to 3. That's why 1 to 3 is not a palindrome. Suppose here, let's see the next example I have written here. Here 5 to 5. Suppose I have taken a number 5 to 5 and reverse this number. Now I am going to reverse this number 5 to 5, 5 to 5, 45. So both are equal. The entered number is 5 to 5 and the reverse number is 5 to 5. Both are equal. So this is called palindrome. So any number, so if you enter number from the keyboard and if you reverse that number, then even that reverse number equal to original number, then that is called a palindrome. Now let's see the program. Here I have included the basic header files as usual, and here I have taken a math.h header file. Why? Because here I am doing the mathematical calculations. That's why here for some identification purpose, here I have taken mathematical header file. Maybe for the functions maybe want to use this header file. That's why I have included this header file. And next here I have taken main method, which is of type void type. Next here I have taken a clear screen for clearing the output screen, and next here I have taken some variables from integer type variables. What are those? N, which is take the value from the keyboard, and a reversed integer initialized to 0. It is reversed integer, remainders, and original integer. All these are going to use in my program. That's why I have taken these variables, and which is of type integer type. And this in printf statement, it is going to ask me to enter integer from keyboard. That's why here I have written and enter an integer, and I am going to take that in from keyboard, and here I have sent that value equal to n. That means here I have taken original integer variable, which is of type integer type. So here original integer equal to n, and that means here the entered integer is equal to original integer. That is why I have written this condition. I am just initializing this entered integer value to this variable value, original integer value. This is the meaning for that statement. And next here I am checking the condition. Reverse integer is stored in a variable. I am going to store the reverse integer in a variable. And here I am writing the condition while n not equal to 0. Here n value means that is entered from the keyboard, which is not equal to 0. That means the entered value is not equal to 0. Then the cursor goes here. Remainder equal to n mod less 10. Here remainder, that means remainder equal to n mod less 10. 10 taken value as base 10. and here I am performing the operation reverse integer equal to reverse integer modulus 10 and base 10 and n equal to n by 10. So these are the same operation. These are the same operation as I performed in my previous program too. So and just if the value is stored successfully, if the value is successful, if the entered integer is not equal to 0, and if the value is stored in successfully, then the cursor comes here and you check the condition. If the original integer equal to which is the reverse integer, then simply print the reverse original integer and output screen, else print the original integer. That means if the original integer equal to reverse integer, that means here I have taken original integer equal to n. That means here I have taken the value from keyboard, and reverse integer means here I am performing this operation. From this operation I got the reverse integer. So I am comparing these two. Whether the entered integer from the keyboard and the reverse integer calculated from this operation are equal or not. If both original integer and reverse integer are equal, then simply print a message on output screen. The entered number is parent number. If the original integer and the reverse integer are not equal, then simply print a message those are not equal. So the entered number is not a palindrome. That is why here it displays 1 2 3 is not a palindrome. Here in the second output I have entered 525, and as soon as I press enter, it displays result. That means 525. Suppose if I am going to in this way, the number is same. So this is the 525 is a palindrome number. So this is the way, and these are the operation, and this is the way. This is check the condition to store the value. So this is the way to perform palindrome operation, and this is the way to calculate the palindrome value by using C compiler, C programming language. Next program. Here I have written a program, an Armstrong number for 3 digits. So what is meant by Armstrong number? Here see the output. Suppose I have taken a 3-digit number from the keyboard 1 2 3. Now suppose what is meant by Armstrong number here? That means cube each number and I add each value. That means 1 2 3 equal to, I am cubing each digit value. 1 cube plus 2 cube plus 3 cube. 1 cube means 1, 2 cube means 8, 3 cube means 27. So add these values. So palindrome means if I enter a number from the keyboard, if the entered value equal to the sum of the cubes of individual digits, that means here I have entered 1 2 3 as a number, and cube each digit, that means 1 cube and 2 cube and 3 cube. Add these 1 cube, 2 cube, 3 cube individually. If the resulted value equal to the entered value or not. If the resulted value equal to the entered value, then it is a Armstrong number. If the result value is not equal to entered value, then it is not a Armstrong number. So try to understand the operation here. See here, let's see the output here. I have taken 153 I have taken this number from keyboard 153. So 153 equal to, and a cube each number, 1 cube plus 5 cube plus 3 cube. 1 cube means 1, 5 cube means 125, so 3 cube means 27. So add all these, we can get 153. Add all these, we get 153. So that is the Armstrong number. So entered number equal to sum of the cubes of the individual number in the entered number. So that is the Armstrong number. Here 153 equal to 1 cube plus 5 cube plus 3 cube. 1 cube means 1, 5 cube means 125, and 3 cube means 27. So add all these, then we get simply this value. So this is the way. So now let's see the program. Here I have included the basic header files, and next we have taken main.h, written main method which is of type void type. Next here I have taken some variables which are all of integer type. Here I have taken number and original number, remainder, result value for storing purpose, and next here I am going to take a 3-digit number. So I am going to calculate Armstrong number for a 3-digit. That's why here it asks me to enter a 3-digit number from the keyboard. That's why here I have entered number from keyboard, and if that number is to, I am going to initialize that number to the original number. And here in the while loop, check the condition. If the original number, that means if the assigned number is not equal to 0 or not. If it is not equal, then simply execute the statement, subsequent statement written under the while loop. So the cursor comes here, and here the condition remainder equal to original number modulus 10, taken 10 as base value, and here the result plus, that means here result plus equal to result plus multiply these remainders and add the cubes of these remainders to result value, and simply original number equal to original number by 10. Then perform this operation. And if after performing this operation, and if the cursor goes here and check the condition if the result equal to number or not. If the result equal to number, that means if the entered palindrome number is equal to the sum of the cubes of the individual numbers in that number, then simply display message that number is a palindrome number. Simply display message that number is not a palindrome number. So this is the output, and simply quit from the program. So as soon as I compile and execute this program, I got this output. So first of all, it asked me to enter a 3-digit number. That's why here I have entered 1 2 3. So as soon as I press enter, displayed 1 2 3 is not Armstrong number. Why? Because here the digit in this number, the sum of the cubes of the digits of the each in this number is not equal to entered number. That's why 1 2 3 is not an Armstrong number. And next output, I have entered 1 2 3, and next as soon as I press enter, it displays 1 2 3 as Armstrong number. Why? Because here sum of the cubes of the digits in the entered number are equal to the entered number. That's why here 153 is displayed as an Armstrong number. So these are the 3 different types of program. How to check whether the entered number is prime number or not, and next how to check whether the entered number is palindrome or not, and next how to check whether the entered number is Armstrong number or not using C compiler. So by using C language, by using this type of operation, we can simply calculate the way we can perform this type of operation by using C compiler. So try to understand the logic behind the program, then only you may able to write the programs on your own. So if you like my explanation, please subscribe my channel. Thank you one and all for watching. Thank you all. Have a good day.